Okay, so I went out the other night and I was just had science playing on my mind. Now I've only got my O levels or year 10 and no real scientific background, but I have been dabbling for a couple of years. Um, Now the whole measurement of space, the theory, the Big Bang theory, everything is basically like the universe is mapped out with light or electromagnetic radiation. Um, the Big Bang theory is based purely on electromagnetic radiation, light moving away from us, redshift, Doppler effect. Now, briefly, redshift or the Doppler effect is essentially we have a electromagnetic frequency, and that frequency can be measured, and if it's in the visible spectrum, that will give us a color. Now, if an object is moving away from us, that frequency gets bigger, and that frequency then will give us another color. Now, if it's moving away from us, it's going to go towards the red end of the visible spectrum, hence redshift. That's the Doppler effect. Now, when you map the universe, or if you look at the Big Bang theory, everything is based on the fact that electromagnetic radiation, or the change of that frequency, is a constant. So because it's a constant, in all the mathematical maps of the universe and Big Bang theory, I've always thought that what if there's an outside factor or an external force that can change that frequency? Now, when I came home the other night, instead of turning on love songs and getting on dating apps, I started researching a few different things, and I was looking for a way of testing or seeing if I could find a test to look at anything that could change the electromagnetic frequency. And what I found was something that I already knew about, Einstein cross. So essentially what the Einstein cross is we've got planet Earth. At 400 million light years from planet Earth is a galaxy. Now at 8 billion light years from Earth is a quasar. Now, due to gravitational lensing and such strong gravitational forces around this galaxy, the vision of this quasar bends around the galaxy 4 different ways, and the focal point or reference point, Earth, we can see a picture that looks like a galaxy with a quasar, 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 quasar. Now, this is due to exceptionally strong gravitational lensing. Now, the distance between the opposing visions or images of the quasar are only a couple of arc seconds, but that is hundreds of millions of light years, maybe hundreds of thousands. But at 8 billion light years from Earth, that distance is so vast that any of these 4 lines of light can go through such a huge difference. They can travel through different gravitational fields, they could travel different distances, depending on what else is affecting this light. This light is essentially bent. So gravitational lensing is a much, much, much bigger version of refraction over huge distances and with different causes. So what we're seeing is bent light. Now, if you could measure the redshift in these 4 light paths, you got 1, 2, 3, 4, and find a delta between any of these, what we would find that if any of these light paths have different external factors and we could get a delta, then we can prove that there is something else that can have an effect on the frequency of electromagnetic radiation. And if we can prove that there is something else, an external factor, that could change the frequency of electromagnetic radiation, we would have to go back to the textbooks. We'd have to remap the Earth. We'd have to remap space, the universe. We'd have to mathematically start the Big Bang theory all over again. And that was my result of a night out in Canberra. Don't you love science?